For example, 46, 47, 48, you choose. Let's start with 48. So y or g of x, whatever you want to call it, it doesn't matter. The integral from 2x to 3x plus 1 apply to sine t to the fourth dt. So this is a function given in the form of an integral, which means I'm only asked to find the derivative. I can't determine anything else. So if I'm asked to find the derivative, then I will differentiate both sides. However, the right-hand side is not ready. I can't differentiate in that form. So this has to wait. So I will have to present this function g of x as a sum of two integrals. Because in order to differentiate the function, the lower limit has to be a number. The upper limit can be anything. And when I split it, first of all, I will have a function still here and a number here, so I have to swap, changing the sign. So can anyone tell us how to continue? Yes, Tony.
I would maybe set that up as 2x on the bottom, then it would be like 0.
That's fine. From sine t to the fourth dt. Awesome. But now here you have to start at the same point.
So then I would go from 0
Yes,
to 3x plus 1.
I agree. Sine t to the fourth dt. And one more step before I can differentiate.
You have to multiply the first one by -1 since you can flip the 0.
Yes, in other words, that happens when I flip the limits of integration.
Yeah.
It's not that I multiply it by -1. When I flip the limits of integration, that changes the sign of the integral. Now all the preps are done. Both integrals are ready for differentiation. They have a number as the lower limit and blah, blah, blah as the upper limit. So I'm ready now to find g prime. I differentiate this, and then I differentiate this. What do I get when I differentiate the first one? Definitely minus in front. And then sine of what? I have to write 2x raised to which power? Fourth power, multiplied by the inner function prime. 2, awesome. Plus, I'll come back and simplify it if I can a little bit later. Plus, sine of 3x plus 1 raised to which power? 4 indeed, multiplied by the inner function prime. 3. So now I cannot do anything to this, but I will simplify it a little bit. I will put -2 in front. And yes, here I have to write 2 to the fourth. So this is sine of 16x to the fourth. And finally, plus 3, sine 3x plus 1 to the fourth power. And this is it. Any questions? Yes, Tony?
Why did you change 2x to 16x to the fourth, but then you keep 3x plus 1 to the fourth?
Because when I take a binomial to the second power, it's our agreement from day one, how many terms do I get?
2.
3 terms.
3.
And when I raise it to the fourth power, I get how many terms? If when I raise 2 terms to the second power, I get 3 terms. When I raise 2 terms to the fourth power, I will get
6.
not 2 more than, 1 more than the power. Binomial squared, I get 3 terms. When I cube a binomial, I get 4 terms. When I raise to power 4, I get 5 terms. 1 more than the power. So I don't want to do that. Okay? I can use Pascal's triangle. I know how to do it, but there is no need to expand 3x plus 1 to the fourth power. Very good question. Excellent. Use the properties of integrals to verify the inequality. 51 through 54. Let's take a look.
That's into that problem.
Yes. We are only asked to find the derivative. A function was given to us in the form of an integral. We were asked to find the derivative. Yes. Which one? 53 it is. Let's take a look at 53. In 53, we have the integral from 0 to 1, e to the x, cosine x, dx. They say this is less than or equal to e minus 1. We cannot determine the antiderivative for this. E to the x, cosine x. We have no way of determining an antiderivative. We are not even asked to do that. We are only asked to show that the left-hand side is less than or equal to the right-hand side. That's all we're asked to do here. Okay, so in this particular case, like before with the squeeze theorem, I have to build this function. I am not even looking here. I'm looking at the function. I have to build it. I have to piece by piece put it together somehow. So I'm going to start with cosine x. Better with x. So x is between 0 and 1. When I apply cosine to it, cosine is applied to a radian, 0 to 1. The difficulty with cosine is that cosine is a decreasing function on the interval 0 radian to 1 radian. So let's graph this function. That's the difficult part with cosine. So this is pi over 2. Pi over 2 is more than 1, so the interval 0 to 1 is here. 0 to 1. This is 3.14 divided by 2 is more than 1. Well, cosine does this. On the interval 0 to 1, the function cosine is decreasing. So cosine at 0 is higher than cosine at 1. So when I apply cosine to all three sides, I must switch the limit. I must switch the inequality symbol. Because cosine 0, cosine x, and cosine 1, this cosine 1, see, is smaller than cosine 0. At 0, cosine is 1. At 1 is much smaller. So that's why I have to use this. That's my starting point. This piece is my starting point. And again, you have to be very careful. If the function is increasing, then you're safe. You keep the inequality symbols as they are. But if the function is decreasing, you have to switch the inequality symbol. Since I do not have this side, I don't care about this. All I know so far is that cosine is less than or equal to 1. Cosine is this piece. Cosine 0 is 1. Now I am going to continue creating the function. So I have to multiply both sides by e to the x. But I have to think, is e to the x a positive number on 0, 1? E to the x, it turns out that it's positive everywhere. Because if I know that this could be positive or negative, I can multiply. I don't know when to switch the symbol in inequality. But this is always positive. So I'm safe. So this is e to the x times cosine x less than or equal to e to the x. Okay. I built this function now. I know that e to the x is less than or equal to e to the x. Fine. And there is a property of the definite integral that says that if function f is less than or equal than function g, the integral from f must be less than or equal to the integral from g. So then I can apply the integral dx on the interval 0, 1. So I created the left-hand side. All I care about is to get the answer on the right. So I see now this is this. All I'm interested in is to see whether this piece is that. If the right-hand side is e minus 1, I'm done. I showed that this integer is less than or equal to e minus 1. But now I have to calculate this side. The integral from 0 to 1 from e to the x dx is which function prime is e to the x? Right, e to the x from 0 to 1, I plug in 1, is e, I plug in 0, minus 1. So I did not do anything to the left-hand side because I couldn't even do anything to the left-hand side. I can't evaluate this. I'm not capable to do this by hand. But the problem was not even asking us to evaluate this. It was just asking us, show that this is less than that. I don't know what it is, but I showed that it's less than that. And like with the squeeze theorem, I built the function slowly. And then apply the property that says if f of x is less than or equal to g of x, the integral from this must be less than the integral of this. Good pick. I would like to look at the limit of the Riemann sum. So I would like you to give me a function, preferably quadratic or cubic. And I would like you to give me an interval. You choose the interval. And let's determine the limit of the Riemann sum and the area, which is the area, and also check with the definite integral. Say it again.
Any quadratic.
Any quadratic or cubic.
7x cubed plus 25x squared plus
plus 7, doesn't matter. Okay, very good. Awesome. And now I need from someone an interval. Now, if you choose an interval that does not start at 0, and you have to cube that, it's going to take a while. So since we chose a cubic function, let's now choose an interval that starts at 0. Because it will be less work.
0, 0, 2.
Awesome. Good. So remember, I'm asked to find the exact area in two different ways. The integral from 0 to 2 from 7x cubed plus 25x squared plus x plus 7 dx. That's one way. And it's equal to, the other way will be limit. As n approaches infinity from the sum from I equals 1 through n from delta x f of x I star. So these are extremely important. So now I'd like to start the prep. What is the first prep in the limit of the Riemann sum?
Find out that.
Exactly, awesome. So I could determine this first to see what to expect. Or I could just say, okay, I'm going to check at the end. It's up to you. Which one do you want to start with? I should have asked that. You want to start by evaluating this first, or you want to start with the limit of the Riemann sum. This is the Riemann sum. You want to determine what? Oh, this one will take longer. We want to start with this. Okay, perfect. So in that case, the prep is delta x. What is it?
2n.
2 divided by n. Awesome. Number 2. Second prep. Very good, awesome. xi. It's 0 plus I delta x. Why 0? Is because we chose the limit, the lower limit to be 0. Good. So this is 2I over n. Awesome. Number 3. What is the third prep? So I have this. I have the inside of the function. What is the next step? Exactly, I need that. So f of 2I over n. Good. So I go back to the function. And can anyone dictate what to write? Yes, I have the 7 times 2I over n to the third plus 25 2I over n to the second power plus 2I over n and plus 7. Clean it up and give it to me without parentheses. Tell me what to write and I will write it. So this is 2 cubed, which is 8. So it's 56I cubed over n cubed plus. So this is 2 squared, which is 4. Awesome. 100I squared over n squared plus 2I over n plus 7. Awesome. This is indeed completely cleaned up. And now I can put all the pieces together to find the limit of the Riemann sum. Awesome. Well done. Okay. So the area then, limit, as n approaches infinity, from sum I equals 1 through n. Delta x is 2 over n, so it does not have I in it. I'm going to put it in front. So now f of x I star. So 56I cubed over n cubed plus 100I squared over n squared plus 2I over n plus 7. Limit as n approaches infinity 2 over n. I will apply the sum to the first term, the sum to the second term, the sum to the third, and the sum to the fourth, correct? When I apply the sum to the first, this piece goes in front as a factor. 56 over n cubed, the sum of I cubed, plus. When I apply the sum to the second term, 100 over n squared, the sum of I squared, plus 2 over n, the sum of I, and plus 7 times the sum of 1. Of course, all of them are from I equals 1 through n. I was just lazy. Are we okay with this? Now I have to remember those formulas. And get those out of the way. What is the sum of 1 equal to? The easiest one first. From I equals 1 through n. What can I replace this by? Say it again. There are 4 formulas that we have. We have them in 5.1. Although in your book they are in 5.2 actually. So the sum of 1. When I is 1, I have 1. When I is 2, I plus 1. When I is 3, plus 1. When I is 4, plus 1. When I is 5, plus 1. When I is exactly n, indeed. Good. What do I replace the sum of I by? n times n plus 1 divided by 2. What do I replace the sum of I cubed by? It's the same, but squared, yes. N squared, n plus 1 squared over 4. And the last one, what do I replace this by? N plus 1 to n plus 1 over 6, indeed. Now I'm ready to get rid of the rest as soon as I can. So limit n approaches infinity, 2 over n. So I have n squared, so 56 over n cubed, n squared, n plus 1 squared over 4, plus 100 over n squared times n plus 1 to n plus 1 over 6, plus 2 over n plus 1 over 2, plus 7n. In this step, I didn't accomplish much other than I've replaced those summation notations. Okay, I'm trying to see what will be the least common denominator. So if I simplify these two by 2, I will still have a 3 in here. This can go away. So this is a 3, and this is a 50. And can I divide 56 by 4? Oh, awesome, I can. So it's, what is it, 14? Awesome. Okay, then I want to eliminate these two. So the denominator will be 3n. I'm not going to simplify this one, but I will simplify one here. Awesome. So the least common denominator will be 3n. Limit as n approaches infinity, 2 over n in front, and 3n. Okay, so let's see. Here I have only n, so I have to multiply by 3. When I multiply 14 by 3, I think I get 42. So this is 42. Now I distribute here. N squared plus 2n plus 1. Plus, this is the denominator 3n. That's fine. So I have 50 and multiply these two. 50, and I have 2n squared plus 3n plus 1. Here I have the denominator of n, but I have to multiply by 3. So I have plus 3n squared plus 3n. And this one needs to be multiplied by 3n. So it's positive 21n squared. So let's do this again. So the least common denominator is 3n. Here I have a 50 multiplied by these two. 2n squared plus 3n plus 1. Here I have 3n, so I only have n, so I have to multiply by 3. So it's 3n squared plus 3n. Here I have to multiply by 3n, so I get 21n squared. And here I have to multiply by 3 because the denominator is n. So 3 times 14 is 42, and I expanded this. Are we in agreement? Any questions on this? It's a lot of work. Okay, so since the denominator is 3n squared, all I'm really interested in is collecting the terms with n squared. Because I hope you remember now that when the limit approaches, when x approaches infinity, if the numerator and the denominator have the same degree, the answer is leading coefficient over the leading coefficient. So you can continue to finish up multiplication and so on and so forth, but I'm only interested in the terms with n squared. So 2 multiplied by 42n squared, 42n squared, plus 100n squared, and plus 24n squared, and plus the rest that I don't care about. All the other terms will not influence or affect the answer. So 42 plus 24 is 68, so 168 times 2. So the answer is 2 times 168 divided by 3. No, it's not 68. I'm sorry, it's 66. So 166 multiplied by 2. So this is 332 divided by 3. Don't blame me. Blame me, Ian. No, just kidding. So now we want to determine this. From 0 to 2, what was it? I have to go back 3 pages. Say it again. Right. Plus 25x squared, I remember, and plus x and plus 7. Now I remember. Good. So this is 7, x to the 4 over 4, plus 25, x to the 3rd over 3, plus x squared over 2, plus 7x. Don't you love this? Versus, yeah. So 2 to the 4th is 16. 16 divided by 4 is 4. So this is 28 plus. So this is 8 divided by 3. And 8 times 25 is 150, isn't it? Am I correct? 25. No.
No, it should be 200.
200, yeah. Good. And plus 4 over 2 is 2, and plus 14. Let me add them first. So this is 30, 44, right? Plus 250 over 3. So 44 times 3 plus 250 over 3. So what is 44 times 3? I got lazy all of a sudden. 44 times 3 and plus 250. If it's not,
Maybe like 132.
I'm not getting the same answer. Let me check. We just made up the function, right? So I mean, it was 7x cubed. It's 25x squared plus x plus 7. That's correct. So 7 x to the 4 over 4, x cubed over 3, x squared, and yes. So one more time. 2 to the 4th is 16 divided by 4 is 4. That's 28. And that's 8 over 3. And that's 2, and that's 14. So this is 30, right? It's 30 plus 14 is 44. And how much is, yes, 200. Oh, yeah. Sorry. Okay. So then 44 times 3. So 44 times 3 and plus 200. Yes, indeed, 332 over 3. The area must be the same, no matter which method we use. So the answer has to be the same, and this is the correct answer, and this is the check.
Okay, then we have to do what we have.
No, you will have to use, but it's not going to be on 3 pages. No. Okay.
So the Riemann sum problem, that wouldn't have had to have been as complicated if we would have been given the amount of subintervals, right? Because then we wouldn't have had to have used the variable n.
But if you're given the amount of subintervals, you're finding an approximation.
Okay.
Then I cannot use, very good question, then I cannot use this symbol. It's going to be a squiggling symbol, approximation. If I don't use this, and I only determine this product from I equals 1 through 10, this is not going to be equal.
Okay.
Without the limit operator in front, the area is not exact. It's going to be an approximation.
Okay.
Very good. I would like to look at a couple of integrals with, we still have 9 minutes. So let's look at a couple of integrals with the substitution rule, okay? You would like to look at definite integrals or indefinite? Or which one you want to pick first? Indefinite? Okay, very good. So for indefinite, let's look at problem 30 on page 417. Cosine of natural log x divided by x, the integral from dx. Let's work on this for 1 second. That's it. I forgot to send the test to Hawaii. So sorry. If you remember, I have that student who's taking the online class. And I forgot to send it. And I wrote in my notebook, and I still forgot I started working with you, and I forgot. Not your fault. Sorry. Okay, so what bothers you here? Well, what bothers me is this function inside of cosine. So I'm going to say, let u be natural log x. As long as du is in the problem. But is du in the problem?
That du had to be the original, so this one by du would have to be natural log, and then u would be the 1 over x. What does that matter?
It's the differential. It's not u prime. It's du, which is the differential of a function, which is f prime of x dx. We're not determining u prime. We're determining du, which is, so if I have a function I'm asked to find f prime is one thing. But if for this function I'm asked to find dy, this will be f prime of x dx. And this is not what I'm interested in. I'm not interested in f prime or u prime. I'm interested in du, which equals the function prime times dx.
Okay.
Good. So then I have the integral from, I have cosine u, and dx over u will be du. So this piece is du, and this piece is cosine u. So which function prime is cosine u? Well, the answer is sine u plus a constant c. However, because it's an indefinite integral, I have to replace u by natural log. So sine natural log x plus a constant c. Is that okay? Good. So let's look at a definite integral with substitution. Like, for example, 36. The integral from 0 to pi over 4 from 1 plus tangent t to the third times secant squared t dt. Okay, so let's look at this. So what bothers me here is this 1 plus tangent t to the third, which I can't expand. I can, but it's awful. So I'm hoping that I can get rid of it in 1 plus tangent x, tangent t. But only if du is in the problem. And du equals secant squared t dt. Is secant squared t dt in the problem? Without a lot of effort, right? I can have some constant factor, blah, 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 but not a lot of effort, yes. Otherwise, I can't make it. And this is u to the third. Pretty nice. But remember, I cannot copy the limits of integration. I have to determine new limits of integration. So this equals the integral from u cubed du. So when t is 0, how much is tangent t?
0.
0. 0 plus 1. 1. Pi over 4. Tangent pi over 4.
1.
1 plus 1. 2. The integral from u cubed. U to the 4 over 4. From 1 to 2. Remember, the constant stays outside. Do not mess with 1/4. You don't need it till the end. When I plug in 2, I get 16. When I plug in 1, I get 1. So this is 15 over 4.